Hi everybody, these are your metric system conversion notes. My goal for you in this lesson is that you would be able to understand what metric prefixes are, how they're used, and then how to convert between metric units using the process of dimensional analysis or the factor label method. What you see here are base units. So notice that they don't have any prefixes in front of them. You see here a meter, which is a base unit, a liter, which is another base unit, and a gram. So I have a picture of a thumbtack here because a thumbtack weighs about a gram. So here you see a chart of metric prefixes that allow you to take a base unit and multiply it by powers of 10. So for example, if you put the prefix mega in front of a liter, you would have a megaliter, or you would have a million liters, or 10 to the 6 liters. At the bottom of this chart, you see prefixes that essentially multiply by the base unit by a tenth, a hundredth, a thousandth, etc. of that base unit. So for example, if you have a milliliter, you have a thousandth of a liter, or 0.001 liters, or 10 to the negative third liters. Here's some more examples of uses of these prefixes. If I say I'm running a 5K race, I essentially mean I'm running a 5, and kilo means times 1,000, or times 10 to the third meter race. Well, 5 times 10 to the third is just 5,000 meters. So you see here, 5 kilometers is the same thing as 5,000 liters. Another example, the volume of a soup can is 284 milliliters. So what I mean there is 284 times, and the milli means times 10 to the negative third, or times 0.001. Well, 284 times 10 to the negative third is 0.284 liters. Finally, I've got an inhaler here. It's at 200 micrograms. This is the symbol for micro. So what I mean is 200, and when I say micro, I mean times 10 to the negative 6 grams. So I'll put a G there. Well, 200 times 10 to the negative 6 is the same thing as 0.002. So 200 micrograms is the same thing as 0.00200 grams. Hey, it looks like I made a little typo here. This should actually be a 4. Sorry about that. Get really comfortable with these prefixes. They're on the back of your periodic table. You have a great chart of them. But you should be able to look at something like this. 1Hg. Know that H means hecto, and know that that means 10 squared grams, or 100 grams. I think it's useful to use the scientific notation simply because it's a lot easier to write. Go ahead and see if you can fill in the rest of these blanks. You can stop this video, and then when you restart it, you can check your answers. Hopefully you did okay with these. Just notice here at the end I had a little typo on this video, so I changed that to micro. It should match your notes now. If you have any trouble with this, make sure you ask about this in class. Once you're comfortable just reading that metric unit prefixes chart, start trying to work on doing some metric conversions using this method called dimensional analysis, or the factor label method. I know that many of you can do these metric conversions simply by moving decimals, and that's great. I'm actually very glad you can do that. It's a very efficient way to convert. But what I want you to do now is to do that same conversion process using this specific method of dimensional analysis, because we're going to use this in chemistry, this process of dimensional analysis, all year long, and the metric system conversions is a great thing to work with just to get used to this process. So we're always going to be following these distinct steps to solve the problem. We're going to write down any inequalities that apply in our problem. We're going to write down the given, And we're going to be multiplying the given by the equalities that we've written down. We're going to write these equalities as a ratio, kind of like you see down below, so that our units cancel, and we end up with the new units that we want. This will make sense when I go through a couple of examples. So this first problem says, convert 23.90 milligrams to grams. So notice here we've got a prefix, m or milli. So in the equalities line, write down what a milligram actually is in terms of grams. So we're going to write down 1 milligram is equivalent to 10 to the negative third grams. That's just a known fact because we know that milli literally takes a gram and multiplies it by 0.001. Once we have that, that's the only prefix we have to deal with here. We're going to take our given, and again, our given is this 23.90, and we're going to start the problem with that. 23.90. We're going to write that with the unit next to it, mg. Now, we're going to take this equality right here, and we're going to write it as a ratio. And we're going to set it up in such a way that we can cancel out or divide out this unit of milligram right here. We want to divide this out. So we're going to take the 1 milligram from our equality and put it on the bottom of our ratio, and 10 to the negative third grams goes on the top. Remember, grams is the unit that we're looking for. So now it's just a matter of doing some simple calculations. We're going to take this 23.90, we're going to multiply that by 10 to the negative third, and you can use your, you could just do this in your head. If you want to use your calculator, you would hit that negative 3, and then you're going to divide by 1. So it's 23.90 times 10 to the negative third divided by 1. And when you do that, you're going to get an answer of 0.0239 grams. And that's it. Here's a problem that's a little bit more involved because it's got 2 prefixes in it. That just means we're going to write down 2 equalities. So the first equality is, we know that 1 hectogram is equivalent to 10 squared or 100 grams. We also know that a microgram is equivalent to 10 to the negative 6 grams. I am just looking off that chart that's in your notes there, or on the back of your periodic table. Now I'm going to start the problem. So I start with what's given, and I'm going to write that down here. 0.0678 hectograms. Now I have to multiply this by some kind of a ratio that's going to allow me to divide out that hectogram. So I'm going to take this first equality that I wrote down, and I'm going to write 1 hectogram as the denominator so that that unit will cancel out. And then I'll put 10 squared at the top. You could even physically cancel these units out if that's helpful for you to see that. We're going to keep going because we're not actually at the unit that we want, which is micrograms, so we need to multiply by 1 more ratio, this second one right here. Now notice that the unit that we want to get rid of or divide out is grams, so we're going to need to take 10 to the 6 grams and put that in the denominator so that we can get that unit to cancel out. So we're going to put 10 to the negative 6th grams in the denominator and 1 microgram as the numerator. Notice again that unit cancels out. Now to solve this, we're going to take 0.0678 times 10 squared divided by 1 times 1 divided by 10 to the negative 6th. And for your answer, you're going to get a pretty big number. It's going to be 6,780,000 micrograms. Big answer. So again, anything that's in the numerator, you multiply by. Anything that's in the denominator, you divide by. So So hopefully with these examples you can start trying some of these conversion problems, and we'll work on them in class.